Okay, so here's another example. This one I'm going to do another little trick um, that I know that makes this go a little bit faster. So this one, none of the denominators are the same. But if you'll note that if you take this one and factor, which is what we always do, then factor out an x, and that becomes x times x minus 2. We see that these two over here are the factored form of this one right here. So what I'm going to do is I'm going to try to get the denominator on this side to equal the denominator on that side, then they'll just cancel out, okay? And a quick trick that you can do that is just to do what I call the bow tie. So you're going to multiply this number down here times this number. So cross multiply right there. You're going to take this number and cross multiply right there, okay? That's just going to get your new numerators, but you also have to get your common denominator by multiplying down here. Now, the reason I'm going to do that is because I only have one factor down here and one factor down there. If I had a whole bunch of factors, I probably would not do this. So again, because I just have one factor down here and one factor down here, I do the bow tie. Okay, bow tie is okay when each denominator has only one factor. Okay, so that's when it's okay. So I'm going to multiply x minus 2 times 1. Well, that's just going to be x minus 2. Now I'm going to multiply x times a minus 2x. That's a minus 2x squared. Okay, I just multiplied those two together, and now down here, I'm going to multiply those two together. Well, we know what happens when you multiply x times x minus 2. We see right here, we get x squared minus 2x. Okay, so when our denominators are the same, they just cancel out. Okay, so what I have up here is a negative 2x squared plus x minus 2 equal x plus 3. So what I have here is a quadratic, and the quadratic, I need to solve it by setting it equal to 0. So I don't like the fact that it's negative, so I'm going to add 2x squared minus x plus 2. So this side all becomes 0. I added 2x squared, I subtracted an x, and I added a 2. So this side becomes 2x squared. My x's add to 0, and that ends up giving me 5. Okay, so let me move this out of the way. Okay, so I don't have a next term, so I don't have to worry about factoring. So I picked a really good example. This is going to come out to be imaginary. Negative 5 equals 2x squared. Divide by 2, divide by 2. X squared equals negative 5 over 2. How do you get this by itself? You take the square root of both sides, and x equals plus or minus I, take the negative out, square root of 5 over 2. Now, there's a bunch of things I could do with that, and I think it's just because I made this example up. I got an imaginary number, but that's a good time to review imaginary numbers because they're definitely going to be on the semester exam, but I do not think you'll get I's in any other part of this assignment. Okay, so here's another one. Another example, x plus 6 over x minus 3 is equal to x plus 4 over x minus 2. Okay. What do I have here? This fraction is equal to that fraction. That's super simple to solve. Just cross multiply. X plus 6 times x minus 2. Or you could think about I'm multiplying both sides by x minus 2. And what happens over here? It cancels out. Okay, that's how you want to think about it. What are you doing over here? You're multiplying both sides by x minus 3. It's going to cancel out over here. and you're multiplying that by x minus 3. Okay, so that's really what's happening when I cross multiply. I'm just not showing my canceling out. Okay, so I've got x plus 6 times x minus 2 and x plus 4 times x minus 3. Okay, remember the original restrictions, my x can't equal 3 and my x can't equal 2 because it was x minus 3 and x minus 2. Okay, this becomes x squared plus 4x minus 12. This becomes x squared plus x minus 12. Okay, this is subtract x squared from both sides. Okay, I get 4x minus 12 equals x minus 12. Add 12 to both sides. Okay, 4x equals x. Subtract x from both sides. 3x is equal to 0. Divide both sides by 3, and x is equal to 0. So, x equals to 0 is not in either one of my restrictions, so x equals 0 is the solution. Okay. Again, if you need more examples or if you get stuck on a problem, send me the problem and where you're stuck, or come see me with where you're stuck, and I'll try to give you a boost. Remember, let's see, what are some of my hints have been? When you have a fraction over here, you can combine it, okay? So that and then if they can, the denominators can cancel out. So get a common denominator on this side so that you end up with one fraction on this side, one fraction on the other. The fractions, the denominators will sometimes be the same and they'll cancel out. If you can, put denominators that are the same together. It makes it super easy. Then you just have one fraction on one side, one fraction on the other. All you gotta do is cross multiply. Yeah, we started off this one with just one fraction. All you had to do was get rid of the denominator. Okay, be sure you check. I do know that a couple of the problems in your Springboard book, you do have extraneous solutions, because you will have an extraneous solution if the solution that you come up with is in your restrictions. Okay, so if this came up to be -2, then we would have said it was an extraneous solution and there would be no solutions. So just be sure you understand that you still have to check for restrictions at the very beginning. The restrictions are on each fraction. Okay, so again, check It's Learning for your assignment. I will put the assignment on the calendar. I will put your assignment on the calendar. So all you have to do is check the It's Learning calendar to see what the assignment is. Okay, thanks for watching and listening.